formula notes. Let's look at the back side. In problem number 2, 3m squared plus 2m plus 3 equals 0. We need to make sure that the equation is set equal to 0, which it is. And so now I want to identify a, b, and c. A is next to m squared, b is next to m, c is the constant. And now I want to take those numbers and plug them into the quadratic formula. So I do the opposite of the b value, which is 2, plus or minus the square root of b squared minus 4 times a is 3 times c is 3. And my fraction bar goes under all of that, not under the equal sign. And I divide it by 2 times the a value, which is 3. And now I need to simplify. So the opposite of b is negative 2. And now I want to do the discriminant inside the square root. So 2 squared is 4, and negative 4 times 3 is negative 12. Negative 12 times 3 is negative 36. So minus 36. And then underneath is 2 times 3, which is 6. So inside the square root, I still need to do 4 minus 36, which is negative 32. And so now it's a matter of simplifying the square root of negative 32. So first of all, I want to pull out the negative sign. So I get square root of 32 times square root of negative 1. Now into the next column. I need to adjust my paper. Okay. So I have negative 2 plus or minus, now square root of 32. 32 cannot be divided by 25, but it can be divided by 16. So I'm going to take out square root of 16 and square root of 2. If you did square root of 4 times square root of 8, you'll have to break the 8 down a little bit further. And so now I know the square root of 16 is 4. Square root of 2 I don't know. Square root of negative 1 is I. And now I want to look at the 2, the 4, and the 6, the numbers that are not inside the square root. And those three numbers can all be divided by 2. So I want to divide negative 2 by 2, which is negative 1. 4 divided by 2 is 2. Keep the square root of 2 in the I. And on bottom, 6 divided by 2 is 3. And so you can leave your answer in this form, or you can write it as two separate answers, negative 1 plus 2 square root of 2i over 3, and negative 1 minus 2 square root of 2i over 3. And those are our two solutions to problem number 2. Let's look at problem number 4. Is it set equal to 0? Yes, it is. So the number in front of x squared is my a value, which is 1. B is the number in front of x, which is negative 10. C is the constant, which is 41. So x equals the opposite of the b values, the opposite of negative 10, plus or minus the square root b, and make sure that we put the negative number in parentheses, negative 10 squared minus 4 times 1 times 41. And fraction bar under all of this side of the equal sign, divided by 2 times the a value. And now we just start simplifying. The opposite of negative 10 is 10. And then inside the square root, negative 10 squared is positive 100. Make sure it turns out to be positive. Negative 4 times 1 times 41. Negative 4 times 1 is negative 4. Negative 4 times 41 is negative 164. On the bottom, 2 times 1 is 2. Still need to do the subtraction inside the square root. So 100 minus 64 is negative 64. So now I need to simplify square root of negative 64. First step, take out the negative 1, square root of negative 1. So going over to the next column. So x equals 10 plus or minus square root of 64 I know. So I can just write 8 and square root of negative 1 is I. And so now 10, 8, and 2, those numbers can all be divided by 2. And so on the bottom I'm going to get 1, so my denominator is really going to disappear. So I'm doing 10 divided by 2 and 8 divided by 2. That was plus or minus. So my final answer, 5 plus or minus 4i, or if we want to separate those, 5 plus 4i is one solution, and 5 minus 4i is the other solution. Let's keep going down this column. Number 6. Is it set equal to 0? No. So I need to subtract 5 and combine it with its like term. So I have 4k squared plus 8k. 10 minus 5 is positive 5. 5 minus 5 is 0. Now it's set equal to 0, so I identify my a value next to k squared, my b value next to the k, and c is the constant. Now into the quadratic formula. I just realized that back on number 2, my variable was not x, it was m. So all of these I need to change to m, which I'll go back and do white out before posting the key. Right, so I end up with k equals the opposite of the b value plus or minus square root b squared minus 4 a times a, which is 4, times c, which is 5, all over 2 times the a value, which is 4. Now to simplify, the opposite of 8 is negative 8. Square root 8 squared is 64. 4 times 4 is 16, or negative 16. Negative 16 times 5 is negative 80. 2 times 4 is 8. I'm going to go to the next column. So k equals negative 8 plus or minus square root of 64 minus 80 is negative 16 over 8. So I need to simplify the square root. So my discriminant was negative number, so I expect 2 imaginary solutions here. Negative 8 plus or minus square root of 16 times square root of negative 1 over 8. So k equals negative 8 plus or minus, I know the square root of 16 is 4, square root of negative 1 is I over 8. So 8, 4, and 8, those can all be divided by 4. So negative 8 divided by 4 is negative 2. 4 divided by 4 is 1, or just I. And 8 divided by 4 is 2. So there's my solution, or if I want to separate them out, negative 2 plus I divided by 2, or k could equal negative 2 minus I divided by 2. And number 8. 3x squared equals negative 54. First step, I want to set it equal to 0. So I'm going to add 54 to the other side. 3x squared and 54 are not like terms, so I just write out 3x squared plus 54, and negative 54 plus 54 is 0. So when there's no x term in here, I want 3x squared plus 0x plus 54. So my a is 3, b is 0, c is 54. Now in my formula, x equals the opposite of b is 0, plus or minus square root of b, which is 0, squared, minus 4 times a, which is 3, times c, which is 54, all over 2 times the a value, which is 3. So the opposite of 0 is 0. Zero squared is 0. Negative 4 times 3 is negative 12. Negative 12 times 54. I have to stop and think about this one. I believe it's 648. I'll have to go back and check that. And 2 times 3 is 6. Yeah, I think it's 648. So I've got 0 plus or minus. So if I have 0 here, I'm adding or subtracting from 0 doesn't really do anything. So I'm just going to write plus or minus the square root of negative 648. So now I just got to simplify the square root of negative 648. So take out that negative 1. I'm going to run out of space and I'm going to have to write really small here. So square root of 648. So I got to figure out what perfect square goes into 648. So I'm going to take out my calculator and take 648. Can I divide it by 144? I get a decimal. 648 divided by 121, 11 squared, decimal. 648 divided by 100, I know that won't work. 81, 9 squared is 8. There we go. So I'm going to take out, I'm going to separate it into square root of 81 and square root of 8. So, writing really small here. So, plus or minus, separate this into 81 and square root of 8, and square root of negative 1 is I. This is over 6. But I know square root of 81 is 9, but square root of 8 can separate. Square root of 4 times square root of 2. So I end up with plus or minus 9. Square root of 4 is 2. Square root of 2, I can't break down anymore. I'm going to run out of room here. plus or minus, so 9 times 2 is 18, and then my last step is to divide the 18 by the 6. And so my final answer, I'm going to write this right by the original problem here, is x equals plus or minus 18 divided by 6 is 3 square root of 2 I. So I could write that out as x equals 3 square root of 2 I and x equals negative 3 square root of 2 I.